Welcome to the numerical analysis course. We are studying Eigen Values, and in last lecture we studied how to compute Eigen Value for a square matrix V, an eigenvector for a square matrix A. An eigenvector V is a special matrix for this matrix. A is a special vector for this matrix A, that when multiplied A, that we multiply A with V is equal to lambda times V, where lambda is the corresponding eigenvalue. So this vector is a special vector for A, or in other words, this expression isn't true for all possible vectors for a given matrix A, right? So these special vectors or eigenvectors and corresponding eigenvalues, they are very important in many tasks, for example, in electrical engineering, computer science, etc., right? So this product is equal to 0 implies that V cannot be 0. So this is 0. This means the determinant of this A minus lambda I is 0, where I is the identity matrix we studied yesterday. So 1 0 1 in the diagonal and 0 otherwise. Can be of size 2 cross 2, 3 cross 3, 4 cross 4, so on. Right. In last lecture yesterday we studied how to obtain a characteristic equation for a 2 cross 2 matrix, but in this lecture we are going to see to compute a characteristic equation for a 3 cross 3 matrix A. The general structure is like this. A minus lambda I matrix would be A minus lambda I matrix is A minus lambda times I, and if we multiply this matrix, identity matrix, with lambda, each and every element is multiplied by lambda. So we are left with this, putting its determinant equal to 0. This means A11 minus lambda. We suppress this column, this row, and compute the determinant of this remaining matrix. We did it in school for the first time, and then we can proceed row by row, by one row, by one column. It's our own choice, right? So minus A12. So we proceed by first row. We could have proceed by second row, by third row, by first column, by second column, or by third column, right? So we are proceeding by first row. So minus, the first one is plus, then a minus, then a plus. Minus A12, express this column, express this row, and this remaining matrix, we compute its determinant. And then plus 1, 3, and we suppress this row, this column, we left with this matrix, we compute its determinant. And then we multiply this, and if we further work with this equation equal to 0, we reach to this point where it is lambda cube minus A11 plus A12 plus A11 plus A22 plus A33 times lambda plus A11 A22 A plus minus A12 A21 plus A13 plus A11 A33 minus A13 A31 plus A22 A33 minus A32 A23, right, times, this is times lambda squared, this is times lambda. The coefficients, actually we have collected the coefficients of lambda cube, lambda squared, lambda, and the constants finally, plus minus A11, A22, A33 plus A11, A23, A32 plus A12, A21, A33 minus A12, A23, A31 minus A21, A13, A32 plus A13, A31 and A22 is equal to 0. So it's a complex looking equation, but it's very simple, because if we further work with this, we see that given this matrix A, then I'm going to leave here this one. Given this matrix A, we see that this equation can be written as lambda cube minus A11 plus A22 plus A33. This one, you know, we studied yesterday that it is the trace of a matrix. The sum of elements along the main diagonal is the trace. So this is trace of A times lambda squared. So things are shrinking. So things are going to shrink, right? Plus, let's see what can we write this A11 A22 minus A12 A21, right? If we compute the minor M11 of this matrix, the minor one would be suppressing this column and this row, and this A11 minor would be A22 A33 minus A22 A33 minus A23 A32. Let's see what is this A22 A33 minus A32 A23. This one, the first minor M11, and if we compute the minor M22 for this matrix, M22, this one suppress this, and this is A11 A33 minus A13 A31, A11 A33 minus A1, this one. So this is M11, this is M22, and let's see, the third minor is this one A33. So suppressing this, A11 A22 minus A12 A21, this one M33. So this can be written as plus sum of minors along the main diagonal times lambda. And what is this? Well, let's see what is this last quantity. This last quantity can also be written in terms of some function performed on lambda, performed on this matrix A. Right, so let's see what these 6 numbers are. 1, 2, 3, 4, 5, 6. Let's see. Let's compute its determinant and see whether it is the determinant of this matrix A. We compute a determinant like this A11. We can go by first row, for example. A11, and this is A22, A33 minus A32, A23. So if minus A12, this one. So A21 A33 minus A23 A31, and then plus this one A13 and A21 A32 minus A22 A31. So if you multiply them, A11 A22 A33 is plus, but minus here, A32 A23 A32 A23 A11, this is plus here, this is minus here, A11, but actually this is plus here. So here it is minus A12 A21 A12 A21 A33, but it's plus here. This is plus A12 A23 A31, it is minus here. So this is plus A13 A21 A32, but it's actually minus here, and this is minus A13 A22 A31, but it is plus here. So this whole is actually the determinant of this A multiplied by minus 1. So minus determinant of A is equal to a 0. Right. So this is the last and the final equation. We call it the characteristic equation of a 3 cross 3 matrix to compute its eigenvalue. To compute its eigenvalues, the 3 eigenvalues corresponding to this third order polynomial can be computed either directly or using the approximate methods that we have studied in the early or in the first 2 or 3 lectures of this course. Right. Thank you.